As we are live on YouTube, we're going through some pretty tricky questions. We are 24 hours away from A-level maths paper 1. Let me know in the YouTube chat if you guys can see me. Before I start, I'm going to leave this simple differentiation from first principles question as we get started. We are live on the YouTube, link in bio for anyone on TikTok. But yeah, I've got some pretty tricky questions, some very key ideas before your A-level maths exam. Definitely important. I would definitely recommend tuning in. If anyone's in the YouTube chat, please let me know if you can see me, if everything's all good, and if we're live. Ryan's here. Ryan's already on. Perfect. Give me a thumbs up, guys, if everything's good. This is Edexcel Maths. Edexcel Maths, guys. We're going through some hard questions and very key ideas. Very key ideas and hard questions. Give me thumbs up in the YouTube chat if everything is good. Before I start, we're going to give people 3 to 5 minutes just to join up before we start going through these questions. I've got 6 questions for you guys. I'd say all of them uses very key ideas. One of them even covers a very common silly mistake, so I definitely recommend tuning in for that. Ryan says thumbs up. Ryan says thumbs up. It's definitely working. That looks all good. Appreciate that, Ryan. Just gonna make sure everything is working here. Right, cool, guys. We're just gonna give people a few minutes to join up before we start going through these 6 questions I have prepared today. A-level maths paper 1 is coming up. It is fast approaching, guys. A-level maths paper 1 is indeed fast approaching. At first, I was kind of taking the piss, but now it's tomorrow, under 24 hours. I'm sure you guys are all prepared if you're tuning into my lives and watching my TikToks. I'm sure you guys have seen Neil Does Maths, Bison Maths, a bit of Mr. Asprey, Maths of Dan, all great. Using all of us is probably the best way to get that A or A star that you need. We are live on YouTube for anyone on TikTok. We're gonna go 6 past paper questions. Sorry, not even past paper questions, just 6 hard questions. Some Madas, some international Edexcel. And then of course, I'm gonna leave this differentiation from first principles up for a minute. Very key questions, so we're gonna have to go through it. We've seen this sine cos 1 come up for the last 2 years, so if they put this on, it's going to be one of those easier, more accessible questions. We are live on YouTube for anyone on TikTok. Guys, let me know how you're feeling in the YouTube chat before we start. I'm going to start in maybe 3 minutes at 5 past. Let me just make sure everything's all good on the YouTube. Looks like we're all good. People are joining up. Just going to give it a couple more minutes before we start. A couple more minutes. But let me know how you guys are feeling. I'm sure you're all going to be able to get those A stars. Live on the YouTube, guys, going through 6 questions today. I've got a beastly parametric integration question. I posted one today. I've got another really hard one. It is a mad-ass question, but definitely a tricky one. Definitely A star question for sure. Missed the stream yesterday, Bok. Bok, we're live on YouTube right now. Guys, Bok is raising the grey boundaries single-handedly. You saw that guy dual wielding a further maths and an A-level maths paper? Bok is above that. So the fact that you're here seeing these questions is going to help you out. Okay, guys, the way I'm going to do it is I'm going to go through the entire question at once because the recording will be on YouTube. So if people want to watch it before paper 2 or before paper 1 tomorrow morning, then I'm going to go through the whole question at once. It's going to be very clear if you rewatch it. And then from there, I'll take any questions from the chat. Let me know how you guys are feeling and give me a thumbs up if everything is still being heard and seen. I'm a little bit unsure because yesterday that we had some problems. So let me know, guys. Let me know. We're going to be starting in... My time is frozen. Starting in just under a minute, guys. Just under a minute. Looks like everything's all good. Alright. My cat is frozen, guys. Or there's just no chat, I'm not sure. Let me know if you guys can see and hear me. And then we'll be starting to go through these questions. Let me know, guys. Let me know if everything's all good. Ryan said he's happy. Looks like we're all here. Looks like we're all good. Guys, just type in start if you want me to start. Hey guys, I can't stream on TikTok and YouTube. My laptop crashes when I do that, so not sure if the YouTube chat is currently. Let me close it and reopen it. Starting just a minute, guys. Just a minute, we're starting. Pop out this chat. Okay. Okay, so guys, yeah. The topics we're going to do today, we're going to do a bit of first principles, functions, domain, and range. We're going to do some parametric integration, integration by substitution. We're going to solve a very simple trig equation. Okay, people are saying start. And we're also going to do an implicit differentiation question. This implicit differentiation, it's not too bad when you first look at it, but it can be a bit tricky because there are some key parts mentioned in the earlier part of the question that you have to apply at the end. So Just keep that in mind when we go through it. People are saying start. Alright, I'm gonna start, guys. Guys, we are live on YouTube. Just gonna start going through this, make sure everything's on my screen. Okay. So classic differentiation from first principles. We have the y equals sine x, where x is measured in radians. This bit is waffle. We're going to use differentiation from first principles to show that dy dx equals cos x. In this question, they're actually quite friendly. They tell us we can use without proof the sine addition formula, and we can assume that as h tends to 0, sine h over h tends to 1, and cos h minus 1 over h tends to 0. So the first thing we need for this question, guys, we have to recall our differentiation from first principles formula. So say it out loud, type it down, write it down, whatever you want. Just make sure you know this, guys. So differentiation from first principles, we have the f dash x, or dy dx, equals the limit as h tends to 0 of f of x plus h minus f of x all over h. Very key idea, guys. You've got to know this. When you see this question in the exam, it has to be 3 marks, okay? So dy dx, same as f dash x, is a lim of h tends to 0. So the limit as h tends to 0 of sine x plus h. Because remember, we have our function, but instead of putting in x, we're going to put in x plus h. So our function of x was sine x, but now we're going to put in x plus h, okay? It's not sine x plus h, it's sine of x plus h. Okay, that's very key. We put x plus h into our function. We're going to be taking away sine x. So from here, as they hinted in the question, we're going to be using the sine addition formula. We know that sine a plus b is sine a cos b plus cos b sine a. By now and by the time of the exam, this has to be just in your head, has to be instant, okay? So just to be safe, guys, in these questions, you don't actually have to, especially this year, they've become more lenient, but I would recommend, because it takes 2 seconds to write the limit as h tends to 0 for every step. You don't have to do this, but if you want to be safe and it takes 2 seconds, just do it, okay? So rewriting using that sine addition formula, we're going to rewrite this as the limit of as h tends to 0 of sine x cos h plus cos x sine h minus sine x all over h. Now remember what they told us in the question, guys. They told us that sine h over h tends to 1 as h tends to 0, and that cos h minus 1 over h tends to 0 as h tends to 0, okay? So what we're going to do is we're going to do collecting like terms and a bit of factorizing in order to get just our h's. Because remember, we're trying to eliminate the h's and see what we saw in the question. So combining our sine x cos h minus sine x, this will be cos h minus 1 with sine x factored out, okay? And that's exactly what we need. We know that cos h minus 1 over h tends to 0. Furthermore, scrolling back down, we have cos x sine h over h, so that's going to be cos x multiplied by sine h over h. Now remember, guys, we know that sine h over h tends to 1, cos h minus 1 all over h tends to 0. So we split this fraction into sine x multiplied by cos h minus 1 all over h plus cos x times sine h over h. And we know that that tends to 1. So we're going to have sine x multiplied by 0 as h tends to 0. And we're going to have cos x multiplied by 1 as h tends to 0. So our dy dx will be sine x times 0 plus cos x times 1, which is just cos x. So we've shown that dy dx equals cos x. Let me know if you guys have any questions about this. Remember, this could be for a natural logarithm, it could be a to the x. They could ask you different things, but it's always the same principle. Instead of plugging in that x, we plug in x plus h, and then we use rules of logarithms, or in this case, the sine addition formula, to do what we can, and then they may give you information about when h tends to 0, certain parts that you're going to have to try to get to. Remember the information they give you, and then always try and work towards that, okay? They're not trying to trick you, they give this information for a reason. So let me know if you guys have any questions about that, or thumbs up if you want me to go into this function question. I'm going to leave the function question up on just for a second. How do you know when to integrate or differentiate? Oof. Can you give an example? Being lose at 2 e to the x. Unfortunately, I don't have OneNote or anything where I can write the questions live, so I can only prepare the questions before. But I do know there are plenties. I think Bison Maths has a great video on proofs if you want to look at that after. But it's always going to be the same idea. It's always just going to be plugging x plus h. In the example of e to the x, you may have to, for example, rewrite it as e to the x multiplied by e to the h. Then you can use that information and they'll probably give you something in the question for these to start cancelling out as h tends to 0. Just remember, work methodically. Don't get stressed if it's something you haven't seen before. It's always going to be the same pattern and the same idea. So let me know if you guys have any questions, or just give me more thumbs up if we're all happy to move on. Just going to make sure the YouTube is still running. Okay, looks like we are all good. I only see a thumbs up from Ryan. Let me know if people are happy to move on. Let me know if people are happy to move on. I'm just gonna lift my laptop up so it doesn't burn up. Okay, should be alright. Guys, just give me a thumbs up if we're all happy. Ryan seems pretty happy, so I think we're gonna move on to this function, domain and range question. It's a composite function, guys. No other thumbs up? Is it just Ryan here today? Fair enough, Ryan. Looks like you're gonna be raising the grade boundaries. Okay, Pax has given us a thumbs up. Okay, we've got plenty of thumbs up. We'll carry on now, guys. So we have two functions, f and g. They're defined by f of x equals 2x plus 3, where x must be a real number and x is less than or equal to 4. So that's our domain for function f. We have that x must be less than or equal to 4. I'm seeing loads of thumbs up, thank you guys. And then we have our function g, where g of x equals x squared minus 4. X must be a real number and the domain of g must be x is larger than or equal to 1. So whatever we put in f must be less than or equal to 4, and whatever we put in g must be larger than or equal to 1. What we have to do is find the domain and range of the composite function g of f of x. Remember, with g of f of x, we're putting our function f into g, and remember that function f will act on x first, and then the function g, okay? So let's work through it, guys. We have to find the domain and range. We're going to start with the domain, and then I'm going to work through it. So here are our functions, and here's the domains. Remember what goes into the functions? As I said, with g of f of x, f will act on x first, and then the function g will act on that, okay? So we know the requirement for f, so one part of our domain, one condition for our domain, will be that x must be less than or equal to 4. So this is the first thing. We know that that function f acts on x first, and we have to have the x is less than or equal to 4. That's always the case. You don't have to start stressing about the two functions combining. We know that must be the case for f, okay? So putting the function f into g, because remember that's what happens. We put that function f into g. First f on x, and then the g. So putting f into g, we have that 2x plus 3 goes into g, because that is our function f, okay? So 2x plus 3 goes into g. Remember the requirement for g. What is the requirement for g? Whatever we put in, so they tell us that g of x, the domain for that, must be larger than or equal to 1. So whatever we put into our function g must be larger than or equal to 1, alright? But we know when we're putting f into g, we're putting 2x plus 3. Not just x, we're putting 2x plus 3 into our function g. Therefore, x must be less than or equal to 4 in order to satisfy f. And in order to satisfy g, we have that 2x plus 3, our function f, must be larger than or equal to 1. Sorry. So we're going to just do a little bit of rearranging to see the other condition that x must satisfy. Okay? So we have that 2x plus 3 must be larger than or equal to 1. We're going to take away the 3, so we have that 2x must be larger than or equal to minus 2. Divide both sides by 2, we're going to have that x must be larger than or equal to, that should say minus 1, guys, minus 1. Minus 2 divided by 2 is minus 1, okay? Okay, it's correct here. So our two conditions for x, it must be larger than or equal to minus 1 in order to satisfy that domain for g, but less than or equal to 4, because that was the original constraint for our function f. I hope that makes sense, guys. I'm going to move on to part b. Well, not part b, sorry. We're now going to find the range. Now, guys, very key thing here. With these domain and range questions, especially of these composite functions, it might not necessarily be that you just have to plug in the smallest and then the largest value for our domain. It's not always the case. It will be the case in this question, but it's not always the case. And I'm going to explain how you can essentially avoid making that mistake of just plugging in the smallest value for the domain and the largest value for the domain. So this is what I'm saying, guys. Best to draw out the composite function if possible. If you can draw it out and it's an equation that's doable to draw out, we're going to draw it out so then we can establish if we can just plug in the smallest and the largest value of our domain, okay? So remember, the minimum value may not be at x of minus 1, that's why we're going to try and draw it out, okay? So g of f of x will be equal to g of 2x plus 3 because we put that function f into g. Now we know 2x plus 3 squared minus 4 is our function g of f of x, okay? Now, the minimum that this function can be, we know that 2x plus 3 squared, anything squared must be larger than or equal to 0. Okay, guys? So the minimum that this part can be squared will be 0. We have to think what value of x can we put in there to make this positive or equal to 0 thing equal to 0. Okay? Because once again, that is the smallest point of our function, or the turning point, the minimum value of our function. So we just have to rearrange that 2x plus 3 is equal to 0. I'm going to take away 3, divide by 2. So x will be minus 3 over 2. This is great. We can see we have a positive a positive quadratic function. It's going to be a smiley face, guys. Positive quadratic. Okay? So because it's a positive quadratic and seeing that our minimum point is at minus 3 over 2 for our x value, we know that both minus 1 and 4 are to the right of this. They're both more positive. So in this, sorry guys, so in this case, we got lucky. We can just plug in the smallest value of the domain and the largest value of the domain. So plugging in x equals minus 1, we have minus 1 times 2, that's minus 2, plus 3, that's 1, 1 squared, it's just 1, take away 4 is 3. So g of f of x must be larger than or equal to minus 3, and then plugging in, what am I doing? Yeah, then plugging in 4, 4 times 2 is 8, 8 plus 3 is 11, 11 squared is 121. 121 take away 4 is 117. So that's the value of y that we get when we plug in x equals 4. So we have our composite function g of f of x must be larger than or equal to minus 3 or less than or equal to 117. And that's the domain and range, guys. Let me answer any questions. What is the domain and range? When does the inequality flips when we multiply or divide by a negative number? Exactly, yeah. Our pack's already answered, yeah. Perfect. Okay. What is an outbound? Seb's not looking too good right now. How many marks in range question? I mean, let's see how many marks this question was given. I didn't even copy it out. I assume this would be 3 or 4 marks. Nothing crazy, but I'd say maybe even 5 marks. I'm not the best when it comes to knowing the exact mark for every question. But I'd say 4 or 5. Definitely a key question. That domain and range will definitely trick a lot of people out in other kinds of questions. In this one, no, because you just plug in the smallest and the largest value for the domain to get your values of y. But in general, it will catch people out. Someone's on the bike. Sorry, guys. And calculating, do you have to always prove it? No, you don't have to always prove it. I mean, if you have that graphic calculator, then you can simply draw, or sorry, create your graph and then visually look at it and plug in the appropriate x values. The key thing here is just normally the functions will be very friendly and you'll be able to see if you just plug in the smallest and the largest value of your domain in order to find the range. This is Edexcel maths, guys. Edexcel maths. Guys, give me a thumbs up if you're happy with that question and you want me to move on. The next question is a bit of integration by substitution. It's a pretty tricky question, guys. I'm going to be honest. The next 2 questions are not too easy, not too easy. Just give me a thumbs up if we're happy to move on, guys. Give me a thumbs up. Just gonna make sure the YouTube hasn't crashed. Okay, looks like we are all good. Perfect. Ryan's already got that thumbs up. I'm seeing thumbs up, ready to move on. Seeing quite a few. I'm gonna put the next question on. Guys, here's the integral. By the way, this is an integration by substitution question, and they will give you the substitution. Yeah. Guys, let's see if you guys can figure out the substitution in the chat. They will give it to you in the exam, so don't stress. Do not stress about that. Actually, this is probably quite mean of me, but let's see if you guys can guess the sub that you have to use here. I'll give you a clue. It's not obvious and probably would never guess it. I definitely would not guess it, to be honest. So let me know if you guys can guess the sub here. If someone gets it, I'll be incredibly surprised, but do not stress, they will give you the sub in the exam if you get that integration by substitution question tomorrow. If you don't get it tomorrow, there's a good chance you will get it in paper 2, and we're going to be doing even more practice before then. Okay? Oh, Jack, that's almost an amazing guess. Very, very close. Very close on that one. Very close. Yeah, Pax got it. Pax got it. In A level maths, in normal A level maths, they would always give you the substitution. If they don't, then it should be quite an obvious sub, but we haven't seen that so far. So they should give you the sub in normal A level maths. People always just say they will give you the substitution. Obviously, you're always a bit cautious until after the exam, but oh, I think this is Seb. Ah, okay, okay, okay. It's Seb, it's Seb. All right, guys, we're gonna start going through this question. So we have to show we have to integrate with limits pi over 3, upper limit pi over 3, and lower limit pi over 6 of cot cubed x over cosec x, and naturally we're integrating with respect to x. We have to show that this integral is equal to a sixth times a plus b root 3, where a and b are constants to be found. Okay? I'm going to start going through this, guys. I'm going to start going through this. So they will give you this in the question. Just to be perfectly clear, guys, do not stress. They will give you this. We're going to use the substitution u equals sine x. Okay? So just rewriting the integral once again. Upper limit pi over 3, lower limit pi over 6 of cot cubed x over cosec x integrating with respect to x. Now, the first thing we're going to want to do, guys, is we see that a substitution is u equals sine x, right? So we don't like seeing this cot, we don't like seeing this cosec. We're going to rewrite this in terms of cos and sine. So remember, guys, cot x is the inverse of tan x. We know that tan x is sine x over cos x, therefore the reciprocal will be cot x. We have cos x over sine x. So cot x cubed is going to be cos cubed x over sine cubed x. Then remember, guys, cosec x, look at that third letter, it's going to be 1 over sine x, okay? So having cos cubed x over sine cubed x divided by 1 over sine x, that is the same as multiplying by sine x, okay, guys? So we have cos cubed x cos cubed x over sine cubed x multiplied by sine x over sine cubed x, that's just going to be 1 over sine squared x, okay? So rewriting this out again, guys, we have the integral pi over 3, pi over 6, of cos cubed x over sine squared x dx. Now we're getting somewhere, guys. The first thing we have to do in integration by substitution, we're going to change the limits. Remember, there's always 3 things we're going to want to do, guys. 3 things we want to do in integration by substitution. Change the limits, change that dx to a du, and do whatever we can inside the integral. Make any substitutions that we can. It's very, very formulaic. If anything, you guys should be happy if you see integration by substitution come up in your exam. It's always the same idea. There may be some hard trig identities, but it's always the same idea. You should be relaxed and you should work methodically. Do not panic. So anyway, we already know that sine squared x, well, we know that sine x is u, so sine squared x will be u squared, but we'll get there in a second. So changing the limits, all we have to do is plug in our x limits and set them equal to u. So going back to our sub, we have that u equals sine x. So what we have to do is plug in pi over 3 and pi over 6 to change our limits. So sine of pi over 3, you can put it in your calculator, or let's not let me scroll. Okay, you can put it in your calculator, or you can know your exact values. Sine pi over 3, that's root 3 over 2. I would recommend just putting it in your calculator. You know, this is decide your university. I would recommend just making sure you're getting the right answers. Then you won't be stressing about your exact values. So sine pi over 3 is root 3 over 2, and sine pi over 6 is a half. So our upper limit will be root 3 over 2, and our lower limit will be a half. Remember, we're changing our x values to u values. So continuing on, guys, I think the next thing is going to change that dx to a du. It's not letting me scroll down, give me a sec. Okay, so to change that dx to a du, we're going to differentiate our sum, okay? So we have that u equals sine x, therefore du dx, we know that sine differentiates to cos, okay? So we have that du dx equals cos x. Remember, we want this in the form as dx equals something, okay? Because we're trying to get rid of that dx. So we're going to multiply over by dx, then let me get my mouse, then divide over by du. Sorry, divide over by cos x. So we have that dx equals du over cos x, okay? Now we're going to make this sub. So we have the integral with our new limits of root 3 over 2 and lower limit a half of cos cubed x over u squared. Remember, it's u squared because we had sine squared x. Sine x is u, it's u squared. And instead of dx, as we found here, it's going to be du over cos x. We see cos cubed x over cos x. Cos cubed x over cos x, it's just cos squared x, okay? So we're going to have cos squared x over u squared du, okay? Now remember, guys, we have the sub that u equals sine squared x, okay? So u equals sine squared x, we currently have cos squared x. We're going to use that classic trigonometric identity. I say probably, almost definitely going to come up in some way tomorrow or in paper 2. Sine squared x plus cos squared x equals 1. We rearrange it to get cos squared x equals 1 minus sine squared x. And remember, we know that sine squared x is u squared, but let's do it step by step. So we have that cos squared x equals 1 minus sine squared x. So now we have this full integral. We made that substitution in for cos squared x. And now we know that sine squared x equals u squared. Same as before. Same idea as before, guys. So writing the full integral perfectly with no x's now. Upper limit root 3 over 2. Lower limit a half. We change those from x to u. We have 1 minus u squared over u squared integrating with respect to u. In this case, nothing tricky, nothing scary. We can just split these up into 2 fractions. 1 over u squared, take away u squared over u squared. And that's just 1. So minus u squared over u squared is just minus 1, okay? So we're going to split these up into fractions. Once again, 1 over u squared, take away 1. Now remember, we don't like having that u in the denominator, so we're going to rewrite this, as u to the power of minus 2. So we have the integral with upper limit root 3 over 2 and lower limit a half of u to the power of minus 2 minus 1 du. Easy integral, raise that power up by 1, divide by the new power. So u to the minus 2, that's going to go up to u to the minus 1, and we're going to divide by minus 1. So we're going to have minus u to the minus 1, that is just negative 1 over u, okay? And then that minus 1 integrating with respect to u, that will just simply be minus u, okay? Just integrating a constant here. Now, a little trick, guys, and this is very, very key in your exam. They're probably going to use it in some kind of show that question, potentially. Potentially, I can't predict what's going to come up, but this is the kind of thing that you have to know. If we multiply everything in our integral by minus 1, we flip the limits. It's a very key thing we have to know. If we multiply everything within our integral by minus 1, we flip the limits. So in this case, you don't actually have to do it. I just decided to make the answer look a little bit easier, and it will help us to get to the answer that we're trying to get. You would get there eventually, but here's what we're going to do. It's going to make our answer and our life a little bit easier, okay? So we're going to multiply everything by minus 1 and flip the limits. So we're going to have 1 over u, minus 1 over u times minus 1 is just 1 over u. And instead of minus u, we're going to have plus u. And now we have half as our upper limit and root 3 over 2 as our lower limit. I hope that's making sense, guys. Then from here, we plug in a half. 1 over a half, that's just 2. 1 divided by a half. Denominator of the denominator goes to the numerator, so that's just 2. Plus u, so that's plus a half. 2 plus a half, that is just 5 over 2. Then plugging in root 3 over 2, 1 over root 3 over 2, that's just 2 over root 3. And then plugging in root 3 over 2 into our u is just root 3 over 2. So we have 2 plus a half to be 5 over 2. Take away everything when we're plugging in that root 3 over 2. So that's going to be 2 over root 3 plus root 3 over 2. We're just going to quickly rationalize this denominator, because remember, guys, by the end of the question, let's just scroll back up to what we're trying to get to. By the end of the question, we want to factor out a sixth, okay? So it would be great if we could get our denominators as a sixth, okay? Or 6 in the denominator. So first thing we're going to do, we obviously can't have that root 3 down there. We are going to rationalize that denominator. Just keep on looking what we're trying to get to, guys, okay? So rationalizing that denominator, multiply the top and the bottom by root 3. We have 2 root 3 over 3, okay? Now, looking at everything in our bracket, we want that all over 6. So we're going to multiply the left fraction by 2 on the top and the bottom, and this right fraction by 3 on the top and the bottom, okay? So 2 root 3 times 2 is 4 root 3, 3 times 2 is 6, and then root 3 times 3 is 3 root 3, 2 times 3 is 6. So we have 4 root 3 plus 3 root 3, okay? So we're going to have 5 over 2, take away, all in the brackets, 4 root 3 plus 3 root 3. That's going to be 7 root 3 all over 6. So we have 5 over 2 minus 7 root 3 over 6. Now remember, guys, they wanted us to factor out a sixth in this question. So what we're going to do is we net that 5 over 2 to be something over 6. So we're going to multiply the top and bottom by 3, okay? Multiply 2 3 to get 6, and 5 times 3 is 15. So we have 15 over 6. Take away 7 root 3 over 6, So we can factor out that sixth to be left with a sixth times 15 minus 7 root 3. So therefore, our value of a will be 15, our value of b will be 7. That's the integration by substitution, guys. I'm going to look at the chat and see if you guys have any questions. How did I know to rewrite the integral? They do give us a substitution of u equals sine x, so we want to write everything in terms of sine and cos x when we see that. Yeah, we use partial fractions when the degree on the numerator is less than the denominator, okay? Why is domain and range harder than integration? I couldn't agree more. Yeah, remember, it will be long division. If your degree on the numerator is larger than or equal to the denominator, so for example, we have 2x plus 2 and then 2x in the numerator, you do have to use partial fractions. Okay, that's a bad example, but if you have just some terms and it's just as x on the denominator, and some terms just as x on the numerator, you're going to have to use long division partial fractions, for example. Yeah, that's it. Okay, yeah, exactly is in the chat, guys. Exactly is in the chat. Exactly. If that numerator power is larger or the same, then you're going to have to use the division. Okay, I'll give you guys a quick recap of the question. I'm not going to go through all the working again, just a quick recap. But give me a thumbs up if you're ready to move on. Thumbs up if you're ready to move on. But if not, then we are just going to do a quick recap. So, quick recap, guys. We had this integral. We were told that u equals sine x, okay? Because of that u equals sine x, we saw this was absolutely unacceptable to have everything in terms of cot and cosec. We did not like this, we did not want this, okay? So we wanted to rewrite everything in terms of cos and sine in order to use our substitution, okay? From here, we did the classic integration by substitution, change the limits, change that dx to a du, and make any substitutions that we can within the integral. Very systematic, be a robot, okay? I mean, it's true. We did what we can, we did some cancelling. From here, we saw the easiest way to integrate it after using our trigonometric identity to get rid of that cos x. Okay, I'm seeing a thumbs up. To get rid of that cos x, we could just split this up as a fraction, make further substitutions, and then from here, we just had to integrate the polynomial, raise that power up by 1, divide by the new power. Nothing scary. From there, we did use the trick of multiplying by -1. When we multiply everything in our integral by -1, we flip the limits. Okay, key thing to know, especially in show that questions. But yeah, guys, we got I think I have about 4 or 5 pages of working for this parametric integration question. I'm gonna leave it up for. I'm gonna leave part A up if I can. Yeah, I'm gonna leave part A up just for a minute. Hope you guys can see all that. Okay, part B won't fit in. I'm gonna leave up part A just for a minute if you guys want to have a read. I'm just gonna quickly make sure the YouTube is still running. I'm always a bit. Okay, we are still running. We are all good. Alright, guys, this is a pretty horrendous parametric equation question. It is it's long, guys. It's very long. There are some key things you need to do, key things you need to check. Um, yeah, it is it's long, guys. It's long. Have a little read through. Just gonna make sure everything's all good. Okay. All right, guys, just put start in the chat if you want me to start going through it. I'm gonna have a sip of water because this one this one's pretty big, guys. It's a pretty big question. This is horrible, yeah. This would be question 14, 15, 16, whatever it goes to this year. This is going to be definitely towards the end of the paper. If you see an easier question after this one, then just go for that one first, okay? Just give me a second, guys. I was seeing a few people say start. Pax wants a minute. Pax has been very loyal, so I might just give you guys 30 more seconds before I start. Just gonna read through the question quickly. I'm gonna read through the question, okay? So first of all, they give us the graph of the curve. This is always helpful. Always use this in the question. So we're told the figure above shows a curve known as a cardioid. Do not worry about that, guys. Do not worry about that. Which is symmetrical about the x-axis. That is something we're going to remember, okay? When it's something symmetrical, this may kind of incentivize us later on in the question when finding areas to potentially multiply by 2. A little bit of foreshadowing there. We're told the curve crosses the x-axis at the points A, -2, 0, and the points B, 6, 0. So we already have our x-coordinates where this curve crosses the x-axis. That's useful, we should be thankful. The point P is the maximum point of the curve. I'm seeing maximum point. I haven't even read the question yet, but we know maximum point dy dx is going to be equal to 0. This is a turning point, okay? We're told the parametric equations of this cardioid are x equals 4 cos theta plus 2 cos 2 theta, and y equals 4 sine theta plus 2 sine 2 theta. We're told that our range of theta must be larger than or equal to 0, or less than or equal to 2 pi. Or sorry, just less than 2 pi, okay? First part of this question, part A, we have to find a simplified expression, guys, for dy dx in terms of theta, and hence find the exact coordinates of P. So quickly put in the chat, guys, how are we going to find dy dx for parametric integration? I'm going to say it in 2 seconds. I probably won't even have a chance to read the chat. So for dy dx, we're going to use dy d theta over dx d theta. That is how you find dy dx in these parametric equation questions, okay? And we are going to have to find the coordinates of P. Therefore, we're going to have to find where dy dx equals 0, okay? So starting to go through this, guys. As I've said, dy dx will be equal dy d theta over dx d theta. We have our equations for x, we have our equations for y, okay? Now we have to differentiate each one. So we have that x equals 4 cos theta plus 2 cos 2 theta. Differentiating 4 cos theta, we know that cos differentiates 2 minus sine, okay? So we're going to have minus 4 sine theta, and then differentiating 2 cos 2 theta. So we know that cos will differentiate to minus sine, same thing. And then remember, when differentiating, we're going to multiply it by what's inside of our function, 2 theta, differentiated. That's going to be 2. 2 times 2 is 4. So we have minus 4 sine 2 theta. Once again, cos theta goes to minus sine theta, and we multiply it by everything in our function differentiated. Bit of chain rule. And then we have the y equals 4 sine theta plus 2 sine 2 theta. Okay, guys? Differentiating this, we know that sine differentiates to cos. We can ignore that constant. So we have that 4 sine theta differentiates to 4 cos theta, and 2 sine 2 theta, same idea, exact same idea as before. We're going to multiply it by 2, sine goes to cos, so we're going to have 4 cos 2 theta. Nothing too bad so far, guys. Putting dy d theta over dx d theta, we have 4 cos theta plus 4 cos 2 theta over minus 4 sine theta minus 4 sine 2 theta. We can quickly see they want it simplified. We can divide the top and the bottom by 4, okay? So we're going to have minus, because we have that negative in the denominator, I can factor out that negative 1 from the denominator and put it just in front of the fraction, makes it look a little bit nicer. So we have cos theta, or the negative of cos theta plus cos 2 theta over sine theta plus sine 2 theta. That's dy dx, okay? Now remember, our point P, scrolling back up to the question, point P is a maximum point of the curve, okay? So dy dx will be equal to 0 at our point P, okay? So carrying on, guys, dy dx is equal to 0. Remember, we don't have to worry about the denominator, because we can't divide by 0, or that just doesn't matter. When we have a fraction, all we care about is that numerator being equal to 0, because we could just multiply through by whatever constant we had on the denominator. So 0 times whatever we had would just still be 0. So we only care about the numerator. So we're going to check that cos theta plus cos 2 theta equals to 0. Now, guys, this is a classic question, classic trigonometric question, okay? With cos 2 theta, we're always going to be using that cos double angle ID, so we're going to be able to make it quadratic. We're going to have everything in terms of cos theta, okay? We don't want that cos theta and that cos 2 theta, we won't be able to solve that, okay? So from here, we have cos theta plus cos 2 theta. We're going to use that cos double angle ID to get everything in terms of cos. We know there are 3 versions of our cos double angle ID. In this question, because we want quadratic, everything will be in terms of cos theta, okay? So for cos 2 theta, we're going to use cos 2 theta equals 2 cos squared theta minus 1. That's the one where we can get everything in terms of cos, okay? So exactly how I wrote down here, I'll get everything in a nice quadratic. So we have that cos theta plus 2 cos squared theta minus 1 equals 0. Now factorizing, what multiplies together to make minus 2 and adds together to make 1, that's going to be 2 and minus 1. Okay, so we're going to have 2 cos 2 theta plus 2. That will simplify to cos theta plus 1. And then we have 2 cos theta minus 1. We set these equal to 0. So now, remember guys, we are trying to find those values of theta. We want those values of theta for the dy dx to be equal to 0. So then we can use those values of theta to plug them in to our parametric equations to find x and y for our coordinate P. It's a bit of a long, well, it's definitely a long question. This would be at the end of the paper. But if you can do this, you can do anything. You should be very confident if you can do this. So once again, we're trying to solve theta, okay? So looking at this right bracket here, we need that cos theta plus 1 is equal to 0. Therefore, cos theta will be equal to minus 1. Now guys, just putting this in your calculator, don't even bother to remember those exact values. Inverse cos of minus 1. Make sure you're in radians, guys. This is actually a good point. I have my calculator just now in degrees. Make sure we're in radians. So cos theta of minus 1, guys, I'm going to put it up here. It's just pi. Don't worry about exact values. You can always just draw the graph if it is a bit faster. Just want you to show the process yourself so you don't get stressed and stay relaxed, okay? We're also going to solve that 2 cos theta minus 1 equals 0. Therefore, cos theta will be equal to a half. Put it in your calculator, you get the value of pi over 3. But remember guys, what do we know about cos? So after we find that primary value, we have to do 360, or in this case, because we're in radians, 2 pi minus our primary value, which was pi over 3, in order to get that secondary value. So our secondary value will be 5 pi over 3, okay? So we have 3 values of theta. We have theta equals pi over 3, and theta equals 5 pi over 3. What we have to do is find which of these values of theta correspond to our coordinate P, okay? So we're going to have to find which of these values of theta correspond to the coordinate P. Now if I quickly scroll up, the reason we have 3 values of theta is because there are 3 points where our dy dx will be equal to 0. One will be this maximum point P, one will be the symmetric minimum point, we can call it P dash, doesn't matter, and the other will be at this kind of kink in our graph at A, okay? So we're just going to have to find which one corresponds to P. Now we can quickly see that the y values here, for this minimum point, we're going to have a negative y value. For this maximum point, we have a positive y value, and here y equals 0. So all we really have to do is just plug it into our y parametric equation and see which one gives us a positive y value for each of these values of theta. Okay? But I'm pretty sure I'll go through the whole thing just to make you guys very clear on why we're doing everything. So for theta equals pi, our first solution, when theta equals pi, we plug this in. So plugging it into our x equation, we have 4 times cos of pi, that's minus 1. And then we have 2 times cos of 2 pi. Guys, just plug this in your calculator. Do not stress about doing any exact values. So just plugging this in your calculator will give you minus 4 plus 2, because cos of 2 pi is 1, cos of pi is minus 1. So we're going to have minus 2 as our x value, which is already suspicious because we know our point P was in the positive x values. So from here, you can already move on. I'm just going to work through step by step. Then plugging in theta equals pi. We have sine of pi. Just drawing out that graph. We know that's going to be 0. Sine of 2 pi, drawing out that graph, it's also going to be 0. So our y will be equal to 0. This is minus 2, 0. So we now know, this is actually going to be useful for the next part of the question. We now know that when theta equals pi, this corresponds, I'm going to scroll back up to the graph to make things very clear. This corresponds to our point A, which we know has coordinates minus 2, 0. So now we know the corresponding value of theta. This is going to be helpful for the next part of the question, which is even longer, guys. It's even longer than this part, okay? Don't worry, this is actually the easy part of the question, okay? So so carrying on, we know this corresponds to minus 2, 0. Now we're going to check our other two values of theta. And as I said before, all we want to check, guys, is whether they give positive or negative y values, because we know that the points that these will correspond to will either be our maximum point, where that y value was positive, or our minimum point, where the y value was negative. So plugging them in to y equals 4 sine theta plus 2 sine 2 theta, I'm not going to waste your time, guys. You simply put this in your calculator. If you plug this into your calculator of 4 sine pi over 3 plus 2 times sine 2 pi over 3, plug it in, this gives you 3 root 3. If you want, I can even do it right now. I'll do it right now, guys, just to make sure I'm not chatting. R's times 4, 3 root 3. R's a plus 2 times sine 2 pi over 3. It does indeed give you 3 root 3, guys. I hope you can see that. 3 root 3, okay? I'm not going to do the second one. The second one, we plug in 5 pi over 3. This gives you minus 3 root 3. Remember where our point P was? It was that positive y value. So we know the corresponding value of theta for P will be pi over 3 because it yielded a positive y value, okay? So exactly as I wrote here, guys, as pi over 3 yields a positive y coordinate, we're going to use pi over 3 to find now the x coordinate of P. We've already found the y coordinate to be 3 root 3. Now we're going to find that x coordinate. We're getting there, guys. We're getting there. And I even mentioned here 5 pi over 3 or 5 over 3 pi yields a symmetric point at the bottom. Yeah, guys, my calculator is horrendous. My calculator is very bad. I haven't used it in a while. Okay, so yeah, we've already established that our y value when plugging in pi over 3 is 3 root 3. Then plugging it into our x parametric equation, we have 4 times cos pi over 3 plus 2 times cos 2 pi over 3, just putting it into that x parametric equation. So that would be 4 times a half, cos pi over 3 is a half, and then cos of 2 pi over 3 is indeed minus a half, so we can have 4 times a half is 2, 2 times minus a half is minus 1, so we can have 2 minus 1, we get an x value of 1, and we already knew our y coordinate was 3 root 3. Therefore, our coordinates for P would be 1 and 3 root 3. I hope that makes sense, guys. I hope that makes sense. Hope that makes sense. That was only part A, guys. We still have a part B coming, but this is definitely a good thing to know. Definitely a good thing to know, to be honest. They like to give you multiple solutions, and they like you to use that graph in order to find out whether we have to get positive coordinates, negative coordinates. They may tell you something is in the third quadrant, so you know you're going to have negative x's and negative y's. All of these things are key. I'm now going to move on to part B, guys. I'll give you a minute to look at part B. I'll give you a minute to look at part B, guys. So this is a little bit of parametric integration. Nothing too scary. Nothing too scary, sorry. Nothing too scary, but yeah, it's not ideal. Part B is definitely tricky as well. I can promise you that right now, guys. Part B is not good. I'm gonna give it a minute. I'm gonna read the question out slowly. So we have to show that the area of the top half of this cardioid, shown shaded in the figure. We try and I'm gonna quickly scroll up just for a second, guys, to show you the diagram. So once again, there is a diagram. So we have to show the area of the shaded region is given by the integral of limits, upper limit pi, lower limit 0, of 16 sine squared theta, plus 24 sine theta sine 2 theta, plus 8 times sine squared 2 theta, naturally integrating with respect to theta. For part B, can you split it up into 3 integrals? Yeah, we will. The thing is, you can split it up into 3 integrals, or you can just integrate each term separately. So, I mean, you could write it out as 3 integrals, but you can just literally, the same way when you're adding two things, like a polynomial, we can just integrate each term one at a time. So and then we have to find the exact value of the area enclosed by the cardioid. I'm gonna spoil it right now, guys. Because we know it's symmetric, if we find the area of the top half, we can simply multiply it by 2. Okay, nothing scary here. So first thing we have to do, guys, is we're going to recall the parametric integration formula. So remember, we have some key ideas. We have to have our limits in terms of theta, not in terms of x. And then we're going to have the integral of y multiplied by dx d theta, integrating with respect to theta. Okay? So give me a thumbs up if you guys want me to start going through this question. Let me know if we want it up for a bit longer. Yeah, exactly right. Eventually, we know we're not going to be able to integrate those sine squares or cos squares if we had it. Exactly, you have to use that cos double angle ID in order to integrate it. We're going to go over that in a second. Exactly. So you guys want me to go through it? I'm seeing thumbs up. I'm seeing yes. Looks like we're all happy. Okay, looks like we're all happy. I'm going to start going through it, guys. This is an incredibly hard question, guys. This is the last question on the paper. Okay, but all of these ideas with the integral, sorry, and all this like rearranging, everything we're going to be doing, it can be used in any question. Okay, so these are all very key skills. Really good spot with the sine squared 2 theta. That really good spot. We saw it in 2024. We're going to see it again in 2025. I'm calling it now, guys. But we'll see. I'm not going to make any predictions. Okay, guys. We're focusing only on the top half, and then we're going to integrate that. Sorry, we're going to multiply the area by 2. Okay. So firstly, we know parametric integration is going to be our limits in terms of theta, y times dx d theta, integrating with respect to theta. Okay. So we're finding the limits in terms of theta. Quickly scrolling up, guys. We already saw. Sorry about that. The documents. So we already saw they gave us the limits in x already. Okay. We look at b. We look at a. We know our x value of b. Here it is 6, and our x value of a is -2. Amazing. We already have our x values. We don't need to stress about that. So all we need to do is plug those x values into our parametric equation for x in order to find theta. But here's the key thing, guys. Remember what I mentioned in part A. Let's just go through it step by step. So first thing, guys, remember, parametric integration is very similar to integration by substitution. Same ideas. Changing the limits, we find the limits in terms of theta. We know at A our x value is -2. But remember, in part A, we already found the value of theta that corresponds to x equals -2 was pi. Okay? I'm going to scroll that back up really quickly. Remember when we tried out that value of theta equals pi, we got our point A. Okay, so we already know that for A, our lower limit will be pi. We already know that. The lower limit will be pi. Okay? Lower limit, guys, because that is a -2. That will be the lower limit in the x's. Do not try and switch things around. Lower limit stays the same. It will be pi. Okay? Now we have to find x equals 6. So plugging in x equals 6 into our parametric equation for x. Remember, sorry about that, guys. Remember, for the parametric equation for x, let me just get rid of this highlighting thing. I'm sure it's annoying. Okay, that was 4 cos theta plus 2 cos 2 theta, and this will be equal to 6. The only way, because cos is bounded by -1 and 1, another key idea that they love to use in modeling questions, we know cos is bounded by -1 and 1. Whatever we put into cos can only be -1 and 1, so the only way to get 6 with this is such that cos theta and cos 2 theta are equal to 1. Now scrolling all the way back up, guys, looking at our range of thetas, it has to be larger than or equal to 0 or less than 2 pi. So the only way we're going to get 0 for both cos theta and cos 2 theta is such that theta equals 0. So coming all the way back down. So now we know theta equals 0. But remember, guys, that corresponds to x equals 6. The upper limit will be 0. The lower limit will be pi. Okay? Now, before I even carry on, guys, I've already mentioned it once in the stream. I'm going to mention it again. Let's look now. Dave wanted it as the upper limit pi and the lower limit 0. We currently have it the other way around. Remember, to flip the limits, we multiply the whole integral by -1. Okay? Multiply the whole integral by -1 if you want to flip the limits. So we're going to have to be doing that at some point. So do not panic if we start getting everything negative, because remember, we're going to have to multiply by -1, and hopefully we're going to get everything positive. So continuing on, guys. So we already have a parametric equation for y, and we already knew dx d theta. So just continuing on, from part A, we know that dx d theta equals minus 4 sine theta minus 4 sine 2 theta. So now we just plug everything in into that parametric equation. We have our limits in terms of theta, we have our y, and we have dx d theta. Okay, and of course we're integrating with respect to we're integrating with respect to theta. Okay, so plugging in our equation for y and dx d theta, we have 4 sine theta plus sine 2 plus 2 sine 2 theta multiplied by minus 4 sine theta minus 4 sine 2, 2 theta. Okay, we're not even going to factor anything out yet. We're just going to expand this. Okay, but you could if you wanted to. It doesn't matter how you get there as long as you get there. So 4 sine theta multiplied by minus 4 sine theta, that's going to be minus 16 sine squared theta. Now let's be careful here, guys. We have 4 sine theta minus 4 times sine 2 theta. That's going to be minus 16 sine theta sine 2 theta. Okay? But we're also going to have 2 sine 2 theta times minus 4 sine theta. Okay? So that's going to be minus 8 sine theta sine 2 theta. So we had minus 16 sine theta sine 2 theta. Take away 8 more of sine theta sine 2 theta. So that's going to be minus 16, take away 8. That's going to be minus 24 sine theta sine 2 theta. And then we do 2 sine 2 theta multiplied by minus 4 sine 2 theta. 2 times minus 4 is minus 8. Minus 8 sine squared 2 theta. So here we have it all written out, guys. Also, we should be very happy at this point because we have everything as a negative, because we know we're going to have to multiply by minus 1, and the show that had all positive values. So we're quite relieved if we get to this point, okay? So expanding the brackets, this gives us minus 16 sine squared theta, minus 24 sine theta sine 2 theta, minus 8 sine squared 2 theta, integrating with respect to theta, okay? Now, quick comparison to see if that's exactly what we wanted to get in our answer. Is that what we wanted? 16 sine squared theta, yes. 24 sine theta sine 2 theta, yes. 8 sine squared 2 theta, thank God, okay? So we got to this point, all of our stuff is negative. The only difference is their limits were flipped, perfect. Multiply the integral by minus 1, that flips the limits. So to flip the limits, we multiply through by minus 1, as I've wrote here. So we have the integral of pi as the upper limit, 0 as the lower limit, of exactly what we had before, 16 sine squared theta plus 24 sine theta sine 2 theta plus 8 times sine squared 2 theta. Amazing, guy. This is perfect. We got to show that. Now we have to find the area of the top half. So we just have to integrate it. Now I've already seen people were reminding themselves exactly how to integrate sine squared or cos squared, but in this question it's sine squared. So we're going to have to use that cos double angle ID. Remember, if we see sine squared, we see cos squared, we're going to have to use a cos double angle ID. Okay? So here it is, guys. We need sine squared theta. Okay? Actually, sorry, guys. First thing that I decided to do this question is we didn't want this sine 2 theta. We currently have sine theta and sine 2 theta. We don't know how to integrate it. We can't integrate that. We want everything in terms of theta. So we're going to use the sine double angle ID as well here to get rid of the sine 2 theta. We know that sine 2 theta is 2 sine theta cos theta. Okay? And then here we have it. We're going to use the cos double angle ID because we have sine squared theta and sine squared 2 theta. We know that cos 2 theta, using that double angle ID, is 1 minus 2 sine squared theta. We're going to want to make sine squared theta the subject of the formula. So we're going to add over that 2 sine squared theta minus the cos 2 theta, and then we're going to divide by 2. So we're going to have 1 over 2, a half, take away cos 2 theta over 2. So we're going to have to plug that in because we cannot integrate. I'm going to keep on saying it because it's going to come up. We cannot integrate sine squared or cos squared theta. If it doesn't come up in either paper, including the mechanics paper, I'd be very surprised. Okay? And then same idea with the sine squared 2 theta. This time we're going to have to double the angle of our cos. Still a double angle ID, we have to double it. So it's going to be cos 4 theta. Same idea, 1 minus 2 sine squared 2 theta, doubling each angle. Don't get scared if it's 4 theta instead of 2 theta. So doubling it, do the same idea, we're going to add over that 2 sine squared 2 theta. Take away the cos 4 theta, so we have that sine squared 2 theta equals a half minus cos 4 theta over 2. Now we're just going to make all of these subs into our integral. The sine 2 theta will be 2 sine theta cos theta. Our sine squared theta will be half minus cos 2 theta over 2. And then our sine squared 2 theta will be half, take away cos 4 theta over 2. Okay, let's work through it now. So here it is. I've just made the exact substitutions. You can compare it to before. I'm going to give you guys a second if you want to look through that. So we have 16 times a half. That's going to be 8. We're just expanding the brackets now, guys. 16 times a half, that's 8. 16 over 2, so that's also 8. We have minus 8 cos 2 theta. Then we have 24 times 2, that's 48. Then we had sine theta cos theta multiplied by that further sine theta from before. It's going to be sine squared theta cos theta. Then we have 8 times a half, that's just 4. And then 8 times minus cos 4 theta over 2, 8 over 2. So it's going to be minus 4 cos 4 theta. Once again, integrating with respect to theta. Now, last step we have to do here, guys, is we're going to collect like terms, sorry. So we have that 8 plus 4. So we just bring that constant together to get the 12. Everything else, minus 8 cos 2 theta, plus 48 sine squared cos theta, minus 4 cos theta, all remains the same. Okay? So we already know how to integrate 12, we know how to integrate 8 cos 2 theta, we know how to integrate 4 cos 4 theta. And remember guys, if we have that sine to the power of something, sine to the power of something, and it's multiplied by a single cos theta, reverse chain rule, instantly guys, instant. I think I wrote that here, yep, reverse chain rule. So integrating each term, nothing scary. 12 integrating with respect to theta, integrating a constant, just 12 theta. Then integrating minus 8 cos 2 theta. Remember, minus cos integrates to minus sine, and we have to divide by whatever's in our function differentiated. That's going to be dividing by 2. So we're going to have 8 over 2, that's 4. So it's going to be minus 4 sine 2 theta. Okay, so that's minus 4 sine 2 theta. And then remember, I'm going to go through this reverse chain rule in just a second. And then there's minus 4 cos 4 theta minus cos integrates to minus sine. Think of it as a ladder. We have that sine, cos, minus cos. We are currently at minus cos, we're going to minus sine, going up the ladder, okay? And then we're going to divide by this 4 theta differentiated, that's just 4. 4 divided by 4, so it's going to be minus 1 sine 4 theta. Now quickly walking through this reverse chain rule, guys. For this reverse chain rule, did I not write it down? I didn't even write it down. Okay, for the reverse chain rule, we're going to make an educated guess of sine cubed theta, okay? So our guess will be sine cubed theta, raising that power of sine theta up by 1. Okay? From there, we differentiate sine cubed theta. Okay? So differentiating sine cubed theta, we bring that power down to the front and then take 1 off the power. And we're also going to multiply it by sine theta differentiated. So we're going to have, so from sine cubed theta, we have 3 sine squared theta times cos theta. However, we don't have 3 sine squared theta cos theta, we have 48 sine squared theta cos theta. So we have to multiply our educated guess of sine cubed theta and what we got when differentiating by 16 in order to get 48. Because 16 times 3 is 48. So this will integrate to 16 sine cubed theta. If you don't believe me, differentiate 16 sine cubed theta and it will give you 48 sine squared theta cos theta. So from here, guys, we just have to plug in pi and plug in 0. I'm going to quickly say this first. When plugging in 0, 12 times 0 is 0. And then all of these signs, we know that sine of 0 is just 0. So when plugging in 0, we can completely ignore this. We only have to worry about plugging in pi. Okay. So plugging in pi, we have 12 times pi, it's 12 pi. Then we have sine of 2 pi. Draw the graph out or put in your calc. That's short for calculator. So we have sine 2 pi equal to 0. Then, once again, we have sine theta, sine of pi. Sine of pi is 0. Draw the graph, put it in your calc. Cube it. 0 cubed is 0, 16 times 0 is 0, and then sine of 4 times pi, sine of 4 pi, put it in the calc, or draw the graph out, whatever you want to do, that's also going to be equal to 0. So everything here will be equal to 0 when we plug in pi. Everything's equal to 0. So all we have is 12 pi when plugging in pi. And we know when we plug in 0, everything equals 0. So we have 12 pi, take away all of these, which equals 0. So the area of the top half of our shape, that shaded region, will be 12 pi. And then remember, I'm not even gonna look at my own writing. Let's go up to the question. They told us it's symmetrical, guys. Okay, here it is. Symmetrical about the x-axis. So if we have all this area up here to be 12 pi, just multiply it by 2 to get the area of the entire shape. So multiplying it all by 2, going all the way down, guys. I believe, yep, going all the way down. We just have 12 pi multiplied by 2 for the total area, 24 pi, and that is your final answer. For this parametric integration question, guys, it's a horrible question, but very key ideas with trigonometry. Yeah, just a pretty good question. Let's propose that for using a calc. My calc's down. My calc's down, guys. I always imagine the sine graph in my head when looking at these exact values. Okay, let's go back to all the questions. Pax was already saying factor out that minus from before. You could have done it earlier in the question. I just decided to expand everything out first. Either way, you're going to get the same answer if your maths is correct. You don't have to worry about any of that. Okay? Yep. Destiny was getting it before I got it. Amazing. Can I repeat why it's reverse chain rule? I can indeed. When we have sine to the power of something, or anything to the power of something, multiplied by that thing, differentiated. So we had sine squared theta multiplied by cos theta. Sine theta differentiated is cos theta. When we have that, our educated guess will be raising that power up by 1 on, in this example, sine squared theta. So our guess will be sine cubed theta. We differentiate sine cubed theta and compare it to what we had here. Differentiating sine cubed theta will be 3 sine squared theta cos theta. We would have to multiply that by 16 in order to get 48 sine squared theta cos theta. Therefore, our guess would also have to be multiplied by 16 in order to make it differentiate to 48 sine squared theta cos theta. That's why it's reverse chain rule. Looks like people already explained it. How come you do it? How come I do it here? No. This isn't just sine squared theta or cos squared theta in isolation. Because it was multiplied by that cos theta, we used reverse chain rule. If it was just sine squared theta or just cos squared theta, we'd have to use the cos double angle ID. Okay. Yeah, PDF of these questions, it's already on my TikTok. Link in bio, guys. Link in bio. Already on the TikTok. Go up a bit. Yeah, I got you. Where do you guys want me to go up? I'm just gonna go here for a sec. Up a little bit. We have PDF. I got half the answer. Half the answer is quite a few marks. Quite a few marks, guys. Remember, every mark matters. Don't get discouraged if you get stuck at a certain point. You're going to get some marks for doing some working, of course. I hope that's all good, guys. Guys, give me thumbs up if you won the next question. Guys, that was the big hard question. I'm not going to be going for too much longer. That was the big hard question. We've got two more questions. Two more questions. Can you just explain cos 4 theta? Yeah, I can. So because we had that 8 sine squared 2 theta, this is the exact same idea as if we had just sine squared theta. With sine squared theta, that single theta, yeah, we use a double angle ID. So we double the angle of theta, and we normally use cos 2 theta. Because we have sine squared 2 theta, we're going to have to use the cos double angle ID. Doubling the angle will be cos 4 theta. And the same idea, in that double angle ID, we're going to get 1 minus 2 sine squared 2 theta, halving that angle. Okay, nothing scary. What should the tactic be in the exam? Just work through it step by step. Use what you can. Try spot trig equation. Don't panic. If you get stuck, move on to an easier question. Come back to it. And just think of those trigonometric identities. Think of the stuff they told you in the question. They normally give you relevant information. I'm seeing a lot of thumbs up. This live will be on my YouTube after, yes. Okay. Looks like I'm seeing quite a few thumbs up. Guys, keep putting thumbs up if you want me to move on. The next question is nothing tricky. Pax is happy, Pax is happy. Pax is happy, everyone's happy, I'll tell you that. Pax is also raising the grade boundaries, guys. Pax is definitely going to be up there. Promise you that. Pax and Bok. Guys, this was actually on Bison Maths' live stream. Okay, I just think this is such a key thing to remember, and it's such an easy way to make silly mistakes in the exam. I want to make sure you guys can do this. Okay, I'm not going to get to spend too long. I'm sure you guys have seen many questions like this before. I'm also going to use this opportunity to switch my calculator from radians from radians into degrees for this sheet because I'm immediately seeing degrees in this question. We're going to be in degrees. But don't stress too much if you forget the degrees and radians. Actually, it's not ideal, but like, just try to remember it, guys. I'm trying to make you guys feel better, make you feel calmer. If you can remember degrees, remember when you're in radians, okay? Can I say that once more? Once more, when we see that degrees and we see that radians, make sure we switch our calculator to the correct settings. Yeah, was it shift menu, I believe? Shift menu 2, and then choose the appropriate degrees or radians, okay? I saw loads of thumbs up, so I'm just going to go through this question now, guys. Alright, so going through this question, we have to solve this. Very simple, guys. This should be instant, or it will be part of a longer question. Okay? So we have to solve for x. X is larger than 0 and less than 360. Okay? So we're told that sine x cos x equals 3 cos squared x. Okay? So the one thing that loads of students will be doing, they're thinking, let's divide both sides by cos x and then solve from there. Do not do this, guys. Do not do this. Put it on side to that. Exactly. One thing I'd always recommend doing, I'm going to take away sine x cos x from that 3 cos squared x. It doesn't really matter which, if you take away the 3 cos squared x from the sine x cos x, we're just going to get everything, sorry, on one side, okay? So that's what we're going to do, guys. So I did, in my way, I decided to take away sine x cos x from 3 cos squared x, okay? But you can do it either side, it doesn't matter. So I put in big exclamation mark saying we cannot divide by cos x. If you divide by cos x, you have to consider the solution cos x equals 0. Okay? I just would recommend not to do it in these longer questions when you're panicking, the adrenaline's pumping. I would not recommend to just divide both sides by cos x. Okay? Not a good idea. So as I've written down here, guys, take away sine x cos x. We have 3 cos squared x minus sine x cos x. We're going to factor out cos x because we can. We see it in each term. So we have cos x multiplied by 3 cos x minus sine x equal to 0. So we have two solutions. Cos x equals 0. Slap it in the calc. Calc short for calculator, guys, just to remind you. Slap it in the calc. We do the inverse of cos of 0. That's going to be 90. I'm going to put it on the put it on the camera, guys. That's going to be 90. Remember, we're in degrees. Second value of cos, we do 360 minus our primary value. 360 minus 90 is 270. So for cos x equals 0, within our range of 0 and 360, remember to be in your range, guys. They may give you it as 2x, 3x. You have to expand your range to find your values and then divide by 2, for example, in your final answer. So we have 90 and 270, and then we have to solve our bracket equal to 0. 3 cos x minus sine x equals 0. We're going to add over by sine x, divide by cos x. So remember, sine x over cos x is tan x. So we have tan x equals 3. Slap it in your calculator. We're going to have the inverse of tan of 3. That is going to give us, indeed, I'm going to put it up here, it's flip, sorry, it's going to be 71.57 or zero point 0.6 as I've written here. So we have 71.6, and remember, tan repeats itself every pi if we're in radians, or every pi if we're in radians, or every 180 if we're in degrees. Add 180 to get that secondary value of 251.6 within our range of x equals 0 and x equals 360. I hope that makes sense, guys. Let me thumbs up if you want the next question. Thumbs up if you want the next question, guys. This is a very key idea, guys. Very key idea. I see someone's already on the docs. Link in bio for this docs, guys. If you want to be following along, potentially have it up on your screen as well. It's in the bio. It's in my bio. Guys, thumbs up if you want me to move on to the last and final question. This live is not going to be too long because you guys have to be able to get a rest. You have to rest before your exam, sleep well. Maybe tomorrow morning look through some proofs. Just going to make sure the YouTube hasn't crashed, guys. Okay, the YouTube has not crashed. That's always a good sign. My laptop is getting hot, so it may crash soon, but we'll see. I'm seeing a few thumbs up. Pax is happy. Zainab is happy. Everyone's happy. Everyone's happy. Zainab's happy. Pax is happy. Destin's happy. Harry's happy. Why can you not divide it by cos x? If you divide it by cos x, you have to consider the solution of cos x equals 0. Because when we divide by cos x, we're essentially getting rid of a solution. Okay? Hope that makes sense, Daya. Hope that makes sense. Okay. TikTok bio. My TikTok bio has all the links you need. It's in the link tree. I'm going to leave the next question up if you guys want to have a go. It's quite a good question, to be fair. This focuses on the idea that we're going to use previous parts of the question later on in the question. And of course, a bit of implicit differentiation. I missed out the solution. Did I not show the solution here? 71.6 and 251.6. Okay, guys, here's the next question. Implicit differentiation. Remember, with implicit differentiation, whenever we differentiate a function of y, we have to multiply it by dy dx. Okay, whenever we differentiate a function of y, we multiply it by dy dx. Very important. There will be some kind of implicit differentiation on your A-level maths paper. It's almost guaranteed. They love putting in any kind of differentiation, so this is a very key skill. Just make sure this is all in the screen. Okay, guys, just type out or give me more thumbs up if you want me to start going through it. This is the last question of the day. You have to rest before the day of your exam, of course. Last question of the day. Are two questions related? It can't go on like this. It can. It can. Great boundary for an E is 20%. Yeah, you guys are definitely gonna get more than 20%. I'll tell you that. Everyone here will get more than 20%. You guys are all gonna get A's and A stars. Like I can feel it. If you're here and you're watching these questions, you guys are ready for that top grade. I'm seeing some thumbs up, guys. Start and thumbs up if you want me to go through it. Start and thumbs up if you want me to go through it. It's a pretty good question, this one, to be fair. Just waiting for more thumbs up. I'm seeing a few. I'm seeing a few. I'll wait a second more. I'll wait a second more, just for more people. I'll go through a couple predicted topics potentially later. Last question, guys. I want to see a few more starts and go for it. Anything like that, guys. All these questions are either from international papers, Madas papers, um, really old papers, or none of these today are past papers, but they all are from some kind of tricky paper. Okay, everyone's thumbs upping. Okay, sorry guys, my chat is a bit delayed for me, so it takes me a second. Cool. Okay. All right, guys. So here's what we have. We have tan 3y equal to 3 tan x. We want to find dy dx equal to 1 over 1 plus 8 sine squared x. Okay? Our answer is in terms of sine, and we have no y's, only x's. Always good to think about what we're trying to get to. So just differentiating first, we know that tan of 3y, we're going to have to differentiate tan. We know tan differentiates to sec squared. So we're going to have sec squared 3y, and we have to multiply it, whatever's in our trigonometric function, differentiated. Okay, that's going to be 3. 3y differentiated is 3. Well, it's 3 dy dx. We'll get there in a second. Okay, so we have 3 times sec squared 3y, and exactly as I said, because we're differentiating with respect to y, yeah, it's a function of y, differentiating a function of y, we multiply it by dy dx. Okay, then multiplying 3 tan x, we know that tan x differentiates to sec squared. You can ignore that constant, so we have 3 sec squared x. This is good. Now we want it in the form of dy dx equal to something. Okay? First thing we can do before we divide the whole thing on the right by the left, we're going to divide both sides by 3 to make our lives a little bit easier. Okay? Seems obvious, seems easy. Divide both sides by 3. We have sec squared 3y dy dx equal to sec squared x. Okay? So this is what we have after dividing both sides by 3. Now we want dy dx to be the subject of the formula. We're going to divide over by sec squared 3y. Okay? So dividing over by sec squared 3y, we have sec squared x over sec squared 3y. I think you guys can already see I've written it down here, sorry. Our final answer only has x's. We have no y's. Okay? So going back to our sec squared x over sec squared 3y, we want to get rid of these y's, guys. We want to eliminate these y's. So at this point, we're thinking, okay, what do we know? What can we use? Okay? So what do we know? In the question, they tell us right at the start that tan 3y equals 3 tan x. That's the thing that we differentiate. But we know this is a fact. So we know we're going to have to use this if we want to get our y's in terms of x. This is the only way we can see in this question in order to convert our y's into x's. Very important. So always just rewrite the key thing that you know in the question to make your life a little bit easier. Okay? So from here, we're going to use a trigonometric identity. Okay? Because we know tan 3y. We don't know sec squared 3y. And we can't do any integration or differentiation. Don't think about that. We can use a trigonometric identity. Now we can use a trigonometric identity of 1 plus tan squared, I wrote a, x, whatever, yeah, is equivalent to, sec squared a. Remember, if you forget this trigonometric identity, you can write out sine squared x. Sorry, my TikTok froze. Okay, you can write out sine squared x plus cos squared x equals 1. And then for this one, you would divide everything by cos squared x, and that would give you this. If you want to find the other two trigonometric identities, use your sine squared plus cos squared equals 1, then divide through by either cos squared or sine squared, and it will give you your cot trigonometric identity and your tan trigonometric identity, linking with sec and cosec and all that. Okay? In case you forget. So we know this, right? We have sec squared 3y. Okay? So we know that sec squared 3y is going to be equal to 1 plus tan squared 3y using this trigonometric identity. This is great. We know that tan 3y equals 3 tan x. So maybe instead of writing it out like this, you could write it as tan y squared. Oh, sorry, tan 3y squared. So instead of tan 3y, we can set that equal to 3 tan x. We are going to make that substitution, okay? So tan 3y equals 3 tan x. So now instead of that tan 3y squared, we have 3 tan x squared. 3 tan x squared, that's just 9 times tan squared x. Okay, so we have sec squared x over 1 plus 9 times tan squared x. Okay, no need for the calc here, guys. Calc is short for calculator. So we have sec squared x over 1 plus 9 tan squared x. Okay, we're just using trigonometric identities and the information they gave us in the question. Okay. Second thing we need to know in show that questions, always look what we're trying to get to. Always look. We only have sine in our answer. Okay. So what we're going to do is we're going to rewrite the sec squared and this tan squared all in terms of sine and cos. This will help us to get our answer only in terms of sine. Okay. So exactly that. We only have sine in our answer. Okay. We're going to rewrite everything in terms of cos and sine. So sec squared x, look at that third letter, is going to be 1 over cos squared x. And then we know that tan x is sine x over cos x. So tan squared x will be sine squared x over cos squared x. Okay. Now looking at our denominator and our numerator, we want to get rid of these causes. So we're going to multiply both the denominator and the numerator by cos squared x. This is a little trick they love to do, potentially in show that questions. But yeah, this will help us get rid of all these weird, like these denominators within the numerator and the denominator. It's going to make our lives a little bit easier. So exactly that, 1 over cos squared x times cos squared x, it's just 1. 1 times cos squared x is cos squared x, and then we're going to eliminate that denominator, so we're going to be left with 9 times sine squared x. Okay. Now, once again, guys, let's look what we're trying to get to. We still have a cos squared x, so this is not ideal. Not ideal, guys. So we have 1 over 1 plus 8 sine squared x. Okay? We have 8 sine squared x. Now let's look what we have currently. Currently, we have that 9 sine squared x. So what we're going to do is we're going to rewrite this. There's two things that you can potentially already spot. We know that cos squared x plus sine squared x equals 1. And we also don't like that 9 sine squared x. Okay, so we're going to rewrite 9 squared x as sine squared x plus 8 sine squared x. The reason we're doing this is because we saw we had 8 sine squared x in the denominator. Okay, so exactly as I wrote here, we know we need 8 sine squared x. And then you should be able to spot this by now. Yeah, trigonometric identity, we know that cos squared x plus sine squared x equals 1. So when we see this cos squared x plus sine squared x, we see the 1, we see that 1 over 1 plus 8 sine squared x. Exactly what we wanted for dy dx. And that's the answer, guys. I responded in the ID. I did. Although, wait, does that all make sense, guys? Use tan x. Yeah, exactly. The thing that I see. The thing that I used, guys, was what they gave us in the question. They love to do this. You'll get stuck at some point, and you have to think to yourself, there's always going to be a question when they do this. You have to relate back to some information they use in the question. And the reason we use this, remember, this is right at the start of the question, guys. They told us tan 3y equals 3 tan x. We knew our answer only had x's in it, so we had to get rid of those y's. The only way to link x's and y's in this question was through tan 3y equals 3 tan x. Why did the 9 go to 8? It was a show that question. We had to show that it equals 8 sine squared x. Let me just lift my laptop up so it's not burning up. Okay. So because we wanted that 8 sine squared x, we simply rewrote our 9 sine squared x. Let me go back down. We rewrote our 9 squared x as sine squared x plus 8 sine squared x. And the other reason why you may have spotted this is because we also saw that we didn't want cos squared x in our answer. So we used the trigonometric identity of cos squared x plus sine squared x equals 1. And conveniently, it also gets us that 8 sine squared x. It's not cos 2x, it's cos squared x. It's not cos 2x, it's cos squared x, guys. Cos squared x, okay? Is everything good? Guys, give me thumbs up if this all makes sense. Are we happy? I'm seeing people saying it was light. Yeah, that feeling is good when you get that trig identity in the right place, I would have to agree. Looks like we're pretty happy. I'm just scrolling up to any of the questions. But that was the last question of today. You guys need to be rested for that exam tomorrow. But I'm sure if all of this made sense, you guys are going to be more than fine. More than fine. Are we all happy? You guys give me thumbs up and all good if we're all happy. I hope this was good. I hope this was good. Let me know if everything was helpful, guys. I hope the videos are helpful. Guys, if you subscribe to the YouTube, I'll be very, very thankful. Everything's going to be free. I'm going to be doing more live streams, but if you sub to the YouTube, that would really, really help me, guys. That would really help me out. Okay. Motivational speech. Guys, the thing is, here's the difference. Econ students, Econ plus Dal has to give them motivational speech. Do you know why? They don't have that determination in their hearts. Math students, you guys are a level above. You don't need a motivational speech. You guys are so locked in. You're so locked in, you're gonna get that A and A star already. You don't need any motivation. You guys have the determination, you have the passion. There is no need for me to give you a speech. Okay? You guys got this. I'm sure you've been practicing. I'm sure you've been doing loads of past papers. It's all good. If you haven't done my recording, this is going to be all on YouTube. I'm going to be ending it in just a minute now, just so I don't extend the video too long. But yeah, I hope that was all good. I hope that was all good, guys. Thank you for the nice comments, guys. Thank you for the nice comments. Keep looking through all maths videos, not just me. Everything will help you. All right, guys, that's the end of the YouTube stream. I wish everyone luck for tomorrow. I'm gonna post a video in the morning if you guys want to put your proof, just to keep it fresh in the mind. But yeah, I hope everything's good, guys. All right, guys, thank you so much for joining the live. Subscribe if you